In this lesson, we'll try finding the nth term of a quadratic sequence. We won't know at start that it's a quadratic sequence, the sequence that we have 2, 6, 12, 20, 30, and 42, but we will find that out easily by studying the differences between the terms. Between 2 and 6 we have the difference 4, 6 and 12 we have the difference 6. Already we know that it's not an arithmetic sequence, because the first difference is not the same. 8 and then we have 10. And between 30 and 42 we have 12. So then, if it is not an arithmetic sequence, it's worth checking out if it's not a quadratic sequence. Between 4 and 6 we have 2. Between 6 and 8 we have 2. 8 and 10 again 2. 10 and 12 again 2. So that we know that our second difference is the same, so then we have a quadratic. That means that we go to the general form. The nth term is an squared plus bn plus c. And we will need to work with some of the terms of this sequence. In order to make our jobs easier, we will take 3 of these terms, the first 3. This slice of pizza over here. And these are terms 1, 2, and 3. Now what the terms 1, 2, and 3 look like we will remember. Where term 1 means that n gets replaced with 1. So it's a plus b plus c. And we know that term 1 is equal to 2. The second term, term 2, is obtained by replacing n with 2. So that's 4a, because it's 2 squared, plus 2b plus c. And we know that our second term is 6. The third term will be 3 squared, which is 9a, plus 3b plus c. And we know that our third term is 12. In order to find the general rule of our sequence, we need to find a, b, and c. And we will do this by working with the differences. For instance, we've studied the first difference between 2 and 6, which is between the term 1 and the term 2. So we will do term 2 minus term 1, which we know that it's 6 minus 2, which is 4. Algebraically, we are subtracting 4a plus 2b plus c by a plus b plus c. 4a minus a will be 3a, 2b minus b will be b, and c minus c will be nothing. So then term 2 minus term 1 is 6 minus 2, and that's equal to 4. So we get a first equation where we don't have 3 variables. Let's repeat this process. We will subtract from term 3, term 2. Term 3 minus term 2. Algebraically, it's 9a minus 4a, which is 5a. 3b minus 2b, which is b. And c minus c is nothing. 12 minus 6 is the difference between term 3 and term 2. And that's equal to 6. So we get a second equation where we only have a and b. Now from these two, if we make the difference, b and b will cancel each other out. So from these two, if we subtract 6 minus 4, the numbers, we will get algebraically 5a minus 3a, which is 2a. So then that means that 2a is equal to 2. So that leads us to a being equal to 1. When we get to the first of our variables, to a, we can easily go up the ladder and find the next ones. For instance, if a is equal to 1, we can replace in one of these two equations. Let's take the first one. If a is equal to 1, then that means that 3 times 1, which is 3, plus b is equal to 4. And that leads us to b is equal to 1. Already we found our second term. So then we need to find the last one. We need to find c. And we know a and b. We can go in either of these expressions and replace a and b. Of course, we'll take the easiest. We can replace a and b with the values that we got and rewrite the first term. So instead of a, we'll have 1 plus. Instead of b, we'll have 1 plus c, which we do not know, is equal to 2. So then c will be equal to 2 minus 2, which is 0. Now that we have 1 for a, 1 for b, and 0 for c, we can write our general term. Our general term will be then Tn, which is the nth term. A is 1, so it's n squared, plus b is 1, so it's n, and c is 0, so we can stop here. And that is how we find the nth term of a quadratic sequence.